Lesson 9I, Power. Power is denoted with the symbol capital P. It is the rate at which energy is transferred, which is also the rate at which work is done based on the work-energy principle. Power is a scalar and can be calculated by dividing work with time. P equals W divided by T. Its unit is the joule per second or watt, capital W. Let's take a closer look at the formula. P equals W over T. More power means that more work is being done, or work was done in less time. Less power means less work was done, or work was done over a greater amount of time. Here we have an example of an elevator lifting 1,000 kilograms a height of 30 meters in 40 seconds. What is the power of the motor doing the work? Power equals work divided by time. Work in this case is equal to change in potential energy based on the work-energy principle, which is final energy potential minus initial energy potential. In this case, the initial potential energy will be 0, since the object starts on ground. This makes power equal to final potential energy divided by time. The formula for potential energy is mgh. Subbing our values, we have 1,000 times 9.8 times 30 divided by 40. Notice how the units cancel out, leaving power as 7,350 Newton meters per second, or 7,350 joules per second, or simply 7,530 watts. For this next example, let's look at how long you can burn a 60-watt light bulb on the energy available in one regular Mars bar. A Mars bar has approximately 1 million joules, or a megajoule. The formula for power is work divided by time. Isolating for time, we have time equals work divided by power. That's 1 million joules divided by 60 watts, or 60 joules per second. Time is 16,666 seconds, which equals to 4.63 hours. Let's calculate how much energy a 60-watt light bulb uses if you leave it on for a full day. Power equals work divided by time. Remember, work is equal to the change in energy based on the work-energy principle. So power is energy divided by time. Isolating energy, we have power times time. Energy equals 60 watts times 24 hours. Converting our hours to seconds, we have 60 times 24 times 60 times 60. The energy transformed by a 60-watt light bulb in a day is 5,184,000 joules. Of that, only 5% is transformed into light, while the other 95% is transformed into heat. As you can see, this number is huge and represents only a single 60-watt light bulb in your house. Your house has dozens of electrical devices which are using electricity constantly. Your electricity bill would have to report an astronomically large number if it reported your energy in joules. Rather, we use the kilowatt hour for household electrical use. Energy equals power times time, but here we use power in kilowatts, thousands of watts, and time is in hours, not seconds. Let's recalculate the 60-watt light bulb's energy use using kilowatt hours. E equals power times time. 60 watts is 0.06 kilowatts times 24 hours. That makes 1.44 kilowatt hours. This equivalent value is much more manageable when it comes to reporting electrical use.